This is a detailed overview of the thread milling toolpath strategy, where we're going to look at all of the options in the form to show you the effects of the different settings that you have on the toolpaths that you create. The thread milling toolpath enables you to machine internal threads to create a hole that you can screw a threaded bolt into, and you can create external threads for the exterior of a bolt, where it does this using specialist tools and a helical toolpath. Let's take a look at some examples of the different types of threads that you can create. So let's start by opening an existing file. From the project folder, we're going to open Thread Milling Guide example1.crv, press open, and here we have a file that has a set of simple vectors that we're going to use to demonstrate the thread milling toolpath to begin with. Now, in terms of the file itself, our job dimensions, we are working with a width of 250mm, a height of 100mm, and a depth of 40mm. Let's switch over to our Toolpaths command, and as ever, let's always go into our material setup just to ensure everything is safe and appropriate for what we're doing. We've got material thickness here, 40mm, XY lower left, Z0 is going to be on the material surface. And then the rapid Z-gaps above the material, home start position, and the Z-gap above the material are also safe and appropriate for my setup. Then we'll go ahead and press OK. So the thread milling toolpath can be found in the top list of the toolpath operations, and it's this fourth icon, the thread milling toolpath. And if we click on that, that will open up the thread milling toolpath form. Now, before we take a look at any examples, I'm just going to walk you through each section in the form, and then we'll look back at each part in a little bit more detail with some examples. The first section that we have here is where we specify our cutting depths, choosing where we start from and the maximum depth that we want to cut to. You'll notice that we're also displayed the thread length value. This shows us how much of the cut has full threads, and this is greyed out as this is for information purposes and is calculated from the tool that you are using and the maximum depth that you enter in this section here. And we'll look again at this shortly. Next in the form is the tool selection, where the software will display the tool currently applied to this toolpath, where we can change the tool using the select option, and we can edit the tool selected for this particular toolpath using the edit option. Let's press select to take a look at the tools. There are two types of tools that you can use to create your thread, using single point tools or multi-threaded tools. So single point tools have a single point for cutting a single thread at a time, and multi-point tools have multiple cutting teeth and they will cut all of the threads in a single rotation. There are a number of advantages and disadvantages for using either. For example, single point tools provide us with more flexibility when it comes to the threads that they can cut, where you can vary the depth it cuts to allow threads of different pitches to be produced. Also, single thread tools need to machine all of the threads with one cutting edge, and so will be a lot slower to machine the threads compared to the multi-thread tool that will cut all of the threads in a single rotation. So let's stick with a single thread tool. Once you've chosen your tool, moving on down the form, you now need to enter in the thread definition information. And this is specific to the thread that you want to cut. At the top, you can see that we've got a drop-down list of pitch presets, and you can choose from one of a number of standard pitch presets. So the standards are based on the ISO metric thread standard for metric units or the universal thread standard for imperial units. And so selecting one of these options will pre-populate the pitch field with the correct value. Alternatively, you can define the thread pitch by typing in a value in the pitch field. The graphic on the left highlights the pitch, showing you that this value is the distance between the peaks of the thread. If you are using a multi-thread tool, then the pitch field will be greyed out as the pitch is defined by the multi-threaded tool that you are using, and we'll look at an example of that later on. Then you specify the diameter that you want your thread, where you enter in the major diameter, so that's the largest diameter from peak to peak. The fit tolerance is the next one down, and this controls how tight a fit the thread will have. So setting a positive tolerance will mean the tool cuts a slightly deeper thread, and so in almost all practical uses you'd definitely enter a tolerance in here in order to get a thread to run smoothly, and we'll look more at this later on in some of our examples. Then we move on to this button to create circles for internal threads. Now this option creates the correct geometry for us to use to create a circle for internal threads based on the diameter that we've set for the thread in the form, where we can then make use of this vector to clear out the area using a pocket toolpath prior to running the threading toolpath. And again, we'll look at this in our examples. Next up, we need to choose whether we want to create an internal or an external thread type. And then we choose the thread and cut direction. So whether that is left-handed or whether it's right-handed, and the cut direction determines whether or not we want to machine the toolpath by spiraling downwards or upwards. So which direction you choose will purely depend in some part on the relationship between the spindle direction, the tooling and the desired finish. So that's a brief overview of the form. So let's have a look at an example where we can look at how to create internal threads. So in our first example, we're going to look at how to create internal thread holes using multi-threaded tools. Now in my design, I have a series of 8mm holes that I want to machine using an M8 threaded tool to create the M8 holes. So to do this, we need to select the vectors that we want to apply the thread to first. Now, it's also worth pointing out here that the vectors that you select to create the threaded toolpath are purely for location purposes, where it will create the thread from the center of the vector, regardless of what shape it is, and the thread diameter is specified in the form itself. So with those vectors selected, we need to specify our cut depth. So we've got start depth. We're going to put that at 0. So this is the depth at which the toolpath is calculated from. So if we put that at 0, that's going to be at our material surface. Then we need to specify a maximum depth. Okay, now before we do that, I'm actually going to select the appropriate tool that I want to use. I can see at the moment we are currently using a single point tool. So if we use the select option here, we can now go and select the tool that we want from our tool database, in which case we are going to look at using this M8 multi-thread tool. You can see it has a diameter of 6mm and each tooth that we have here is 60 degrees. So for an M8 tool, the pitch is 1.25mm, and we can see all of this information here, and your tool provider will be able to provide you with all of the correct fields that you need to enter in for the tool, the pitch, the tooth size, the offset, and the actual threaded length. Okay, now we can see that the thread length here is set to 15mm, so this is the maximum thread length that we can actually go to. And so if we actually exceed the 15mm in here, once we enter in the maximum depth of cut, then the software will inform us upon calculating the toolpath, prompting us to enter a safer, more suitable maximum depth. Then we can move on to the pass depth. Now it's worth bringing up here that the pass depth for thread milling refers to the sideways passes that the tool has to make to reach the full thread depth required. This has nothing to do with vertical depth, as you'll see in all of the other toolpath strategies. So for this particular tool, the pass depth here is set according to our tooth size, okay? So the 1.083 millimeters that we've got in our example tool here. But as always, you should always ensure that your tool is set up so it's safe and appropriate for the material that you are cutting into and the machine that you are using. And this also applies to your feeds and speeds fields as well. Okay, so this is the tool that we are using. So let's just use the select option there to apply that. So now we can alter our maximum depth. So if I enter a value in here, you'll notice that our thread length has changed. And again, if we put in, say, 7 or say 8, we're seeing instant updates on the thread length according to our maximum depth. Okay, so the thread length here is actually referring to the length of full threads that we can get in a maximum cut depth, which will always be less than the maximum depth, because there will also be the distance between the base of the tool and the tooth that needs to be taken into account, as well as some space that is also required for the lead out as well. So you'll find that the thread length is always less than the maximum depth. So we've seen that the maximum we can go to for this tool is 15 millimeters. In this case, I'm just going to go with 10 millimeters, where we're told that we're going to have a thread length of 8.75 millimeters. So moving on down in the form, we get to the thread definition section. And so here, because we are using a multi-threaded tool, the pitch is already defined for us here, and we can't change that. And that's because it's taken that from our tool information, where this M8 tool that we're using has a pitch of 1 1/4. Okay, and it's greyed out just to help us avoid making any mistakes. Now, if we was using a single tool, a single threaded tool, then we would be able to enter and edit this information. But for multi-threaded tools, this information is preset from the information of the tool itself. So we can't change that unless we change the tool settings. In which this case we don't want to. We want that pitch at the 1 1/4, so we're just going to move on to the diameter now. So for the diameter, as I said, I want to create a series of M8 thread holes. So I need to make sure that the diameter that we are using is 8 millimeters to match that M8. So we'll put 8 millimeters in there. Next, we have the fit tolerance. Again, this controls how tight a fit the thread will have. Now, we generally do the tolerancing on the external thread, but it can be added to the internal thread if you needed to. So in here, if you wanted to add an allowance, you just add in a positive number, which just means that it will cut a slightly deeper thread. In this case, I'm just going to go with 0 in here. We're not going to put in a tolerance, purely because this is just for demonstration purposes, and we are looking at an internal thread hole. Next up in the form, we have create circles for internal threads. Now typically you want to machine out the hole before we thread it, and if we use this option, then the software will create circle vectors that we can then use to pocket out material, where it does all the hard work for us, working out what is the best offset for us to create the vectors for the pocket toolpath to machine that material away, so then we can go in safely with the threaded tool to machine the threaded part away. So when I click on this, you'll see that with our vectors that were currently selected, we now have a series of offset vectors inside of those vectors. So let's just take those offsets that we've just created there from that button, and just to keep our job tidy, we're going to take those, we're going to right click, and we're just going to move them to a new layer. So we're just going to call this layer pockets, and we'll just give that a different colour as well, just so we can differentiate that. Okay, that, and then if we just click outside, we can see they've got their relevant layer colour, just so we know the difference there. And we'll look at using those blue vectors to create our pocket toolpath shortly. So staying with the thread milling toolpath, let's just reselect those outer vectors. So just click to select those like so. And then working our way back down the form, we need to specify our thread type, so internal or external. We know we want to create internal thread type holes there, so we're going to use the internal option. Then we move on and we need to specify our thread direction along with the cut direction. So we're going to machine this from top to bottom. And then we can choose whether we want that to be left-handed or a right-handed thread direction. Now in this case, we're going to go with a left-handed direction. And so what that will mean is we're then going to be screwing our part into the hole, and it will be done so in an anti-clockwise motion. Okay, so that's why we're spiraling down in a left-handed thread type, which just means it's going to be anti-clockwise, going from top to bottom. And we're going to have a look at we're going to have a look at an example of all of the different settings that we have here in an actual machining example shortly. So again, top to bottom, and we're doing that to left-handed, and then we could just simply go ahead and we can calculate that toolpath. And so the software will automatically open up our preview toolpaths form, where we can preview the results in terms of the actual toolpath drawing, and we can actually preview this simulation of what will happen when we machine that. Now before we do that, let's just close out here, and we are just going to jump straight to the pocket toolpath. So we want to machine all of the pocket holes to begin with. So to do that, let's just double click on our page on the layer there. That will select all of the vectors on that layer, so the pocket layer, where we use the create circles for internal holes button in the threading toolpath. So we're going to use these vectors, and we're going to cut down just a little bit more than our maximum depth that we're cutting in the threading toolpath. So here we're just going to go with 10.5. So our maximum depth for the threading toolpath is 10 millimeters. We're just going to apply just a little bit extra there, just to be just to ensure that we're completely clearing that area out. So we're going to go 10.5, and then we're going to choose a tool. So you can see I've already got a 6mm end mill in here, so we're going to go with that in an offset strategy, and then we could just simply go ahead and press calculate. I'm just going to move this up the toolpath list, so it's the first in my list, and then we can just go ahead and preview that. So it's just a series of holes. Let's just make that machined area colour set to material colour, and there are our holes that we can then safely go in with our threading toolpath to just create the actual threaded part of our hole. So if we just check the visibility of that toolpath using the checkbox there. And then what we can do is we can actually highlight the thread toolpath and go ahead and preview that toolpath. Okay, so the preview itself doesn't really show us the threads very well due to the nature of the software. So we're going to take a look at how this would look if we was to machine this, as well as looking at the result of the different thread and cut directions as well. So let's just close out. We're just going to jump back into the thread toolpath, and we're just going to tile our windows here. So now let's take a look at the effects of each one of these different options. So the first one here, we've got a left-handed top to bottom thread. Okay, so you can see the result of that. Second one, we have right-handed going from top to bottom, so you can see how that's going in there. It's lifting out. This time we're going from the bottom to the top, so the tool plunges all the way down to the bottom to begin with, and it works its way up, in this case in a left-handed direction. And again, for the last example, we're starting bottom to top, where we're going in a right-handed motion at this time. So hopefully that little video clip there helps you understand what's actually happening when we machine those thread holes using the various settings that you've seen in the video, so the thread direction along with the cut direction and how that changes when we alter the different options. Okay, so that's our first example. So we're just going to close out here and we're just going to go ahead and we're just going to save this file. I'm going to come out of here, so we're going to go to File, Close. Now we're going to open an existing file. We're going to look at Thread Milling Guide Example 2. So we'll click on that and we'll go ahead and press Open. So this file, we're working in inches this time. We've got a width of 10 inches, a height of 4 inches, and our Z depth is 1.6 inches. And you can see I have a series of identical circles where the diameter is 1¼ inch. So let's just select all of these vectors and we're going to switch over to our Toolpaths tab. Okay, so we're going to go straight into our thread milling toolpath. So now that we've looked at an example of using a multi-threaded tool, we're going to use this example to show how the single-threaded tool works. So to start with, let's just use the select option to select our tool. So we've got this single thread mill tool. So we've got a diameter 3/4 inch, and again we've got a 60-degree angle for the actual tool itself. You can check over the various settings that we've got here. Okay, so our pass depth, we've got that 0.0812, so it's half of the tooth size in this example. And again, any machining that you're doing, please check over the various parameters, geometry, feeding the speeds, ensuring they're all safe and appropriate for your own setup. Okay, so we're just going to go ahead and press select. So you can see it's now changed. We displayed the tool here in our tool selection. So starting at the top, let's start with our cutting depth. So we're going to start at 0. So we're going to leave that 0 there. And we move on to our maximum depth. Okay, currently we've got 10 inches in there. That's way too much, so we need to alter that. So before we alter that, let's just remind ourselves what our neck length is, and we can see that's 3/4 inch in there. Just going to close out. So I'm just going to make that a little shy there, make that 0.7 in this case, and you'll notice that as I've updated that, we're now displayed our thread length as 0. So why is that? Well, if we just work our way down the form a little, now that we are working with a single threaded tool, we're now able to enter in a pitch preset from a drop down list. So we've got all the M numbers here for the metric tools, or we could look at using standard UTS tools here. Okay, so you can click any one of these and then it will update the form accordingly. Now before we did have a value of 1.25 inches in here, which we can just type in and you'll see it will display as a custom setting because we've typed that in. It's not from our preset list of pitches. Okay, so with that 1.25, that the pitch is way too high. It's higher than the actual maximum depth. That's why we're not seeing any threads in there. Okay, so if that happens, then just check over what your pitch settings are. So in this case, going back to our thread definition, we could choose a pitch preset if we wanted to. So we could look at using a 1 inch UTS standard, which is the equivalent pitch of 0.125. Okay, so in this case, I do actually want to create a pitch thread of 1/8 of an inch here, so we'll just go with that. Again, we could just say, let's just make that custom, and you could just type that in if you wanted to. And so with the pitch of 1/8 of an inch and maximum depth of 0.7, we're actually creating a total thread length of 1/2 an inch here. Okay, so onto the diameter. So again, we need to enter in the diameter for the size of the thread. In this case, I want to go with 1 1/4, so it's matching that of the vectors that I already have drawn in my design here. Fit tolerance, we're just going to leave that at 0 for now, and then we're going to use the option here to create circles for internal threads. And again, we're going to use these with a pocket toolpath to clear out all of the material that we can inside of these vectors, so that we've got enough for our thread tool to enter in safely here to actually create the thread at the 1 1/4 diameter. So for those vectors, let's do what we did before. We'll right click and say move to layer, new layer. We're just going to call this one pockets. And again, let's just change the colour of that, and we'll press OK, and we'll come and create the pocket toolpath for those vectors shortly. Okay, so let's move on down. So thread type, again, we're going to do an internal thread type, so we're cutting inside of the vectors. And in terms of our thread direction, we're going to go with a right-handed thread this time. So we're going to go right-handed top to bottom. So it's going to create a clockwise thread direction for us. And then we could go ahead and press calculate. Okay, so it's telling us no vectors are selected, so I have deselected those, so let's just reselect them. So I'm just going to hold down shift, so applying these settings for all 4 of these vectors, and then we could go ahead and press calculate. And again, let's just quickly close out here, and we'll just go ahead and create our pocket toolpath first, so that we can see exactly what's going to happen here. So we're going to the pocket toolpath. Let's just remove that tool. We're going to select a tool. We'll look at using a 1/4 inch end mill here. And again, we just want to cut a little bit. We want to make it just the same, if not a little bit more than the actual maximum depth that we're cutting down to. So let's put in here 0.75. Then we could go ahead and calculate that, and then we can move that to the top of the list, and we could just preview that toolpath. Okay, so that's our pocket toolpath, that's clearing that out. Just put that back to material colour. Okay, so we'll be left with these recesses, and so then what we can do is we can then basically take our thread toolpath. So let's just maximise the 3D view, and we'll take a closer look at what is happening in terms of the tool's movement as it cuts this thread. So if we just zoom in so we can see all of those pleasant looking spirals, you can see we also have this flat circle at the top as well. Maybe we should go to view and use the option here to switch off the colour shaded view temporarily, just so we can see this kind of in its purest form without all the distractions of the material block. Okay, so what's happening? Tool is going to drop down. Okay, it's then going to lead in where it's going to move the tool, or in particular the tooth of the tool, into position at the start depth, where it will continue around in one complete flat circle to create a chamfered top, where it will then spiral down until it gets to the bottom, and then it's just going to do a lead out where it's then going to be retracted, and then it will just leave that hole and move on to the next one. So it creates this flat circle at the top in order for us to create a chamfered top. And the reason for that is it just helps us to avoid any chipping where the material could potentially get very thin when we come to create the first thread if we didn't create that chamfer. Okay, so the reason for that is just to give you a little bit of strength. Okay, so let's just put that back in Z. We'll go to view and we'll switch on the colour shaded view. Then what we can do is we could go ahead and we can preview this toolpath. Okay, so we can take a look at what's going on here. Okay, so again, there isn't really too much to see in terms of what we're actually going to see if we were to cut this, but we'll take a look in a moment at the actual machined footage of this. So we can close out, and if you just double click to open up the thread milling tool. So we're going to look at an example now where we're going to use different thread directions along with different cut directions. So we're going to see this one is the right-handed thread, and we're going from top to bottom, so you can see how that's spiraling down. Second, we've got a left-handed thread where we're machining again from top to bottom, so you can see that spiraling down in the left-handed motion. Next up, we've got the bottom to top, so the tool plunges down to the bottom where it machines its way up to the top in the left-handed direction, and then here we've got the reverse of that from bottom to top, or we're going up in a right-handed direction. So hopefully this makes a little bit more sense. So let's just go ahead and we'll just close out here, and we're going to save this file so you can take a look at that. And now we're going to open up a final example. So we're just going to close out here, and then we'll go ahead and we'll open an existing file. So from the project folder, we're going to open Thread Milling Guide Example 3. Okay, so for our last example, we're going to look at a project where we want to create a decorative wooden screw with a matching internal thread to go with it. Okay, so we're going to look at making an internal and external thread using these 1 1/4 inch diameter circles. I'm going to switch over to the Toolpaths tab, and just to remind ourselves, we're working with a 10 by 10 inch material, and our material depth is 1.612 inches. Check over material setup, so again XY in the lower left, Z0 on the material surface, and check over your rapid Z gaps, home start position, and your Z gap above the material, ensuring that they're all safe and appropriate. So we're going to create both the internal and the external threads in this one file, where hopefully they will mate to create a successful kind of screw and bolt idea. Right, and so we're going to start by looking at the external thread. So we're going to take this vector here. So in terms of my vector drawing, I've got a diameter here of 1 1/4 inch. And that's also what I'm going to set the thread diameter to. So not only have we drew this out, but we're also going to use those values as part of our threading toolpath as well. So with that vector selected, let's go over to the thread milling toolpath. So we're going to look at using the same tool and settings that we used in our last example. Okay, so we're going to go with the 60° 3/4 inch tool there. I'm going to go the start depth of 0 and a maximum depth of 0.7, which is going to give us a thread length of 1/2 inch. So we are creating an external thread type here. So we're going to check this option here to create the external thread. Moving on to the thread definition. So currently in there we've got a custom pitch preset, which I'm going to leave that like we used last time, having a pitch of 1/8 of an inch in there. The diameter is 1 1/4, so again we're going to leave that in play. Now, as we are creating an external thread type, we should think about applying a fit tolerance. It's always a good idea to add in a tolerance here. This is basically where we're overcutting into each of the threads, and just by applying a little bit of an overcut, we should get a better fit. So here we're just going to put in a value of 0.009. It's worth noting as well that with your picked presets, with any click of one of these presets, the form will update the fit tolerance that it thinks is appropriate for that particular picked preset. Okay, so we're just going to go back here. I'm going to put that back to 1/8. And then over here, we're going to put the fit tolerance there to 0.009. So you'll notice in the form, create circles for internal threads is now greyed out, and that's because we are creating an external thread. So this doesn't apply in this case. However, what we do need to do is help ourselves by clearing out all of the material surrounding the upstanding part that we're going to thread to ensure that it's safe for us to go in and then thread the female part. Now, when we create the external part, to ensure it fits inside of the internal thread, we should look at overcutting it slightly. Now, this is not to be confused with the fit tolerance, where the fit tolerance is where the tool cuts deeper into the thread to help us create an allowance. What we need to do is overcut the external part, or the peaks that we're going to be left with on the outside of our thread, and basically we're just going to help for a better fit. We're essentially cutting back at those peaks. And so what we could do is we could look at taking our existing 1¼ inch diameter circle and look at offsetting that inwards by, say, 0.01, and that should hopefully give us a nice fit, which we'll do that shortly. Now, this is one of those, along with the fit tolerance, where you would need to try different offsets and allowances to find the perfect fit, just as you would with a slot together project. And so we'll look at creating that pocket pass in a moment. So moving on down, thread direction, we're going to do this top to bottom in a right-handed direction, and we want to make sure that we replicate this for the internal thread as well. So then we could give that a name. So in this case, let's say we want to call this one thread external. At least I know that's for the external part. We could go ahead and calculate that. Okay, so there is our toolpath, which we'll come back to in a second. Let's just go ahead and create the pocket pass. So we're just going to go into the 2D view, just undraw the visibility of that tool. We'll just switch over to our Toolpaths tab. Okay, so we're going to take this vector, so the 1¼ and offset that inwards by 0.01, and then choose the option to select new. You can see I already have a layer here called Pocket External, so we're going to switch that on. So you can see I've already got a square, so this is a boundary that we're going to cut between this and our newly created offset vector. So we're just going to make that the active layer, so that when I go ahead and create the offset, it's on that particular layer. So you can see it's just come in ever so slightly from our original vector. So that's what we're going to be machining away. Right, and so with that vector, shift and select this vector. I'm going to switch over to our Toolpaths tab. I'm going to use the pocket toolpath in this case. We're going to use a 1/4 inch end mill where we're cutting down 0.7 of an inch. So that's the same as our maximum depth for our thread. Okay, then we could just go ahead and calculate that. We'll move that up the list so this is displayed first. We could go ahead and preview our pocket to begin with. So this will leave us with an upstanding part, which we can see here. And then we can go in afterwards to create the external thread. So we can take that and then we can just go ahead and we can preview that toolpath. It's going to go around the outside to machine the actual threads away. Okay, so where it's actually cut is it's actually cutting the internal peaks. So we wouldn't actually see what we're seeing here, where it's actually machining more of our material away. If we take a look in our 2D view and just switch on the visibility here. So we are going to be left with an upstanding that is the same width as this vector that we've already offset machined away, and then in terms of the actual threading toolpath, this, what you see here inside of the vector, is the actual threads. Okay, so this is the thread part which will create that zigzag pattern if you was looking at that up the X or the Y axis. Okay, so hopefully that makes sense. So we'll just pop that back into its wireframe drawing, put that back in the Z view, and we'll go ahead and tile our windows. That's what we'd see there in terms of the actual toolpath. Right, so let's close out of the preview toolpaths form. So now let's create the internal thread. So we're going to take this vector here. We're going to go over to the thread milling toolpath. Okay, so we're going to go with the same settings as before. Okay, so our maximum depth is at 0.7, giving us a thread length of 1/2 inch. Now, for the external thread, we have the same settings. So where the thread length is on the external part, we're going to have a thread length of 1/2 inch, and then we're going to have a drop, or just a vertical drop of 0.2 to create the total maximum depth of 0.7. So we need to really think about that flat area at the bottom of the external thread for when we come to create our internal thread. So we need to accommodate for that flat at the bottom so that the two can thread into a nice flushed closed finish. So bearing that in mind, what I'm going to do is we're going to change the start depth here to be 0.2. Okay, then we're going to have a maximum depth here of 0.9, which is essentially we're cutting down 0.2, and then we're going to cut down another 0.7. So we're keeping that 0.7 exactly the same. We're just changing the value here to match up with our start depth. And you can see here that we have a thread length here of 1/2 inch. I'm going to use the same tool, same pitch, same diameter. In this case, we don't really need fit tolerance, we've already applied that to the external part. I'm going to change that thread type to internal. We want to create circles for the internal threads as well. Okay, so with that, we can see we've created a new vector inside, which we can use that to pocket out the internal part. We're also going to look at creating another pocket. Okay, now as we've dropped the start depth to 0.2, what I'd like to do is also create a pocket using this outer vector, the 1 1/4 inch, where we're going to drop that to 0.2 as well. So it's going to clear out that entire area with a flat, so that when we come to create this toolpath, that thread toolpath can start at 0.2. We've already machined that part away, and that should allow for our external thread to slot in nicely, thread into our slot where it should close off with a flush finish. And I'll show you some video footage of that later on. Okay, so we're going to go with the exact same thread direction, so right-handed top to bottom. So we want to make sure they're the same so that it matches up with the external part that we've already cut out. So then we can go ahead and we can calculate that, and we can see the thread here. Now before we go ahead and preview that thread, what we'll do is we'll go and create the 2 pocket passes that's required before we actually machine this thread. And what we should do as well is rename this. Let's right click, rename. We're going to call this one thread internal. And then we're going to go ahead and we're going to take the internal vector and we're going to create our pocket pass. We're going to go in with the pocket here. Now we are doing a total cut depth for the thread of 0.9, so we're going to go with 1 inch in here. I go the 1/4 inch end mill, we'll just calculate that. Again, let's just right click, we'll rename that. We're just going to call this one pocket internal. And then we'll just move that up the list. Okay, so that's going to be first, so we're going to cut that before we cut the thread. We're also going to make use of this vector here, where we're going to pocket down 0.2. So we're just going to clear away the first 0.2 to ensure that our external part will fit flush when we come to thread this part into our internal hole. So with that vector selected, let's do a pocket pass. So we're going to do 0.2 in here, and then we're just going to call this one pocket drop down. Okay, so that's just so we know that this is just the drop to ensure that the two can fit flush together. So we can calculate that, and then again we'll just move that up the list. So this is how it will look. So we'll do our pocket internal first. That's using the internal vector that was created from the thread milling form. Then we're going to go with the pocket drop down. So that's using the 1 1/4 inch vector. Okay, so that's the same as our thread diameter. And we can preview that. So it's just going to drop that down a little. And then we've got our thread internal. So you can see it's starting at the 0.2 and it's just spiraling down. So let's just go ahead and preview that to see how that looks. Okay, so what we can do now is we can go and create our cutouts. So if we close out of the preview toolpaths form, in our layers bar, we've got cutout external, cutout internal. We switch that on. So cutout external is this circle vector here. So that's going to cut our external part out in a larger circle to create a kind of bolt effect. And then we're going to go and switch on the cutout internal. That's just a square where we're just going to cut a square out for the internal part. So with that square selected, we're going to hold down Shift and also select this circle. And we're going to go into the profile toolpath where we're going to cut all the way through our material using a 1/4 inch end mill. We're going to machine that on the outside of those vectors. You can add tabs to those toolpaths. Let's edit the tabs. So here we could say, yep, those are okay, and that's fine. So we'll leave that as it is. And then we could just call this one profile cutouts, and then simply calculate that. And then we could preview that toolpath, and we can see our parts cut out of the actual material block where they're held together using those tabs. So let's take a look at how that machined. So here you can see we've just cut the pocket out for the external and the internal threads. And now we're going in on the external part using that single-threaded tool where we're spiraling from top to bottom, going down into that recess. Okay, this is the internal thread. Note that you can see that that thread started a little bit down into the pocket, and that's because of that 0.2 start depth. So here is the part cut out. Okay, it's a little bit rough, and we're just going to wind that into the hole. It goes in perfectly and fits nice and flush, and then we can wind that back out again. So hopefully there you can see the effects of why we dropped our pocket down by 0.2 to accommodate for the bottom of the external flat part of our thread. So let's just close out here, and then we're going to go and save this. So go to File, Save As. I'm going to call this one Example 3 but with Toolpaths. And then we're just going to look at some final options that we've got within the form. So let's go to File, Close. We're going to open an existing file. I'm just going to open Example 1 again. So if we just go to our layers bar, I'm just going to switch off the visibility of the pockets layer, and then we're just going to make layer 1 the active layer. I'm just going to drag a box to select all of those. With those selected, I'm going to press Control to create a copy, and then again Control to create another copy. So we've got 3 lots of these here. Right, let's just switch over to the Toolpaths tab. I'm just going to box select all of those holes. We're going to go into the thread milling toolpath. So with these settings, let's just go ahead and press calculate. Okay, so I don't actually have any control over the order that the software machines these in. It just picks what it considers to be the most efficient order. So you can see it's going up, and then it's going over to the left, down, over to the middle, down, and then over to the right. Now, if I wanted to control the order, then I can do that. So to do that, if we double click back into the toolpath, we can make use of the use vector selection order. So if we just go over to our 2D view, if we just quickly uncheck the visibility there so we can see that a little better. So what we can do is use the vector selection order, and this is where the software basically picks up the order that you select those vectors in and uses that as the order. For example, if I wanted to select this one, followed by these, followed by the right going up, over to the right, then going down, and then I press calculate, you can see now that the software is actually respecting that order as that's what I specified. Okay, so this just allows you to choose the order that you want to machine out those threads. So let's just close out. And then we'll just undraw the visibility there, and then we're just going to go back into our thread toolpath. Now the last option that we have available is to use the vector selector. Now this is the same selector that you'll see in most of the toolpath forms. So if we click on the selector button, so this allows us to select vectors automatically based upon various criteria where we associate vectors with layers and toolpaths. Now we're not going to go into this, but this is covered in a number of other tutorials. So that completes this in-depth guide to the thread milling toolpath. Thank you for watching.